This is the first in a series of videos that I intend to make dealing with the 2100 series carburetor that I use for my DeLorean Carb conversions. This video here is just going to be theory of operation and kind of a history of the carburetor and things like that. I won't actually be tuning it and things like that. I'll do that in a later video. But the 2100 core design, the actual brains of the operation, goes back to 1953. The Autolite company, which itself goes back to, I believe, 1911. Prior to World War II, they just made automotive electrical systems. They started, with magnetos and generators and things like that, and then they, expanded into spark plugs and distributors, and they were pretty much a foremost automotive electrical company prior to the war. And after the war, they decided to get into fuel delivery. And their first foray into fuel delivery was the 2100 and 4100 carburetor. The 4100 is the 4-barrel, which is a good rule of thumb is to think of the 4100 as two 2100s back to back. And I mean, it even looks like two 2100s back to back. It's obviously a little more complex than that, but it's the two carburetors share the same basic fuel metering design and are have a lot of cross-pollination even in parts. But Ford Motor Company in the 1950s started using the Autolite carburetors on their vehicles, 2100 and 4100. And in 1957, as part of Henry Ford II's rehabilitation of the company, they bought a controlling interest in the Autolite company. They did not buy Autolite outright, but they did have a controlling interest in the Autolite company, which unleashed a slew of antitrust lawsuits from other manufacturers. And those continued throughout the 1960s, and then they were ultimately settled right around the turn of the 70s with Ford's divestiture of its interest in Autolite. But as part of the settlement, Ford did get to keep the carburetors. So Ford continued to produce what had previously been Autolite 2100s in-house as Motorcraft 2100s. And they produced those both for themselves and for American Motors Corporation, which also used the 2100 and 4100 series carburetors. After the divestiture, the 4100 goes away. Ford replaces the 4100 with a 4-barrel that they have designed themselves, the 4300 series. The 4300 4-barrels are a Ford design. There's absolutely no connection between the Autolite company and the 4300 series that replaced the previous 4100 series. But in the exciting world of 2-barrels, Ford continued to produce what is basically the same carburetor. There's obviously some differences between the two that I'll show you. But the core design is basically Autolite 2100. Ford produces that for their own use all the way through 1986. And then American Motors was continuing to use the 2100 on the V8 applications. So when Chrysler purchased AMC in 1987, they inherited the V8 application 2100 and they continued to use it all the way through 1991. So one of the historical pieces of trivia is the Autolite knee Motorcraft 2100 series carburetor was the last carburetor to be used on a showroom new vehicle, which would be the 1991 Grand Wagoneers. So the core carburetor has a 48-year production run from 1953 all the way through 1991. Obviously, changes were made along the way, but those are kind of nipping and tucking around the edges. The core carb design itself remained intact all the way from 1953 through 1991. Now, this here is a Ford-produced 2100. Any 2100 that has the word Motorcraft cast into the top casting is a Ford-produced 2100 after the Supreme Court settlement. And it differs minimally from the Autolite predecessors of the 1960s. Like, for example, the chimneys. The Motorcraft 2100s have much larger chimneys. The Autolites is a very small chimney. The air horn itself actually changes the shape of the air horn. This particular carburetor originally had provision for vapor recovery, evaporative emissions. Prior to this, it'll just be flat across the top here. There won't be any loss for a barb. Obviously, the barb has been pulled and plugged on this one. We don't do vapor recovery. But no Autolite 2100s had any provision for vapor recovery. People didn't worry about vapor recovery in the 1960s. So I'm going to guesstimate that this carburetor, this particular casting, probably dates from right around 73, 74 maybe, somewhere along there. The very beginnings of emissions. Ford, the Autolite 2100s do choke pull-off inside the choke housing. There's a piston inside the choke housing that actually is vacuum-operated piston that cracks the choke open when you start the engine. Ford went to external pull-off mechanisms. They started with a pull-off that is integrated into the top casting, and then they eventually transitioned to a pull-off that is externally mounted, that we don't use on these Peugeot manifolds. This is a Peugeot manifold, and I don't use that particular model 2100 because it puts the pull-off uncomfortably close to the distributor. So this would be an early 70s 2100 that has the pull-off integrated into the top casting. But here's a little curiosity. When Ford took the piston out of the choke housing, they did not change the molds that they're using to cast them. So inside the later model choke housings is the original chamber for the piston, the cylinder. It's still there. It's empty. There's no piston in it. And I'll show you that later. But, I thought it's curious that they just continued using the original molds, even though pull-off had been relocated. And there's a variety of other differences. The Motorcraft 2100s go through a couple of different accelerator pump designs. They all work the same way, but they're shaped a little bit differently as you move through the years, which differs from the Autolite designed accelerator pump housing, which again it operates exactly the same, but you're going to have some differences just in the external shape of it. For most of them, the diaphragm itself is interchangeable, however. So it's not like you have to worry about a slew of different diaphragms. The diaphragm is the same, it's just the shape of the housing changes. Autolite 2100s did not use a 1/8 MPT fuel attachment. They used a flare fitting. You had a metal fuel line came in, and you had a flare fitting that attached it to the carburetor. The Motorcraft 2100s, this is tapped 1/8 MPT for a carburetor mounted fuel filter. But if you happen to own one of the Autolites that has the flare fitting, you can just put a flare to MPT adapter and then continue to use a fuel fitting just like a later Motorcraft. I've done that, and I'll show you that later. But this is a Ford Motorcraft produced 2100 using the Autolite original design for all intents and purposes from, I'm going to say, 1974, let's say. Let me show you how fuel delivery works on a 2100. This is obviously a Motorcraft 2100, but in Autolite 2100 is operationally identical. This is the top casting. This top casting is a little bit older than the one that's on the car because it has no evaporative emissions barb. It's just flat across the top. Autolite 2100s are similar. They're flat across the top as well. One of the things you'll notice between an Autolite 2100 and a Motorcraft 2100 is when Ford did the redesign, they rounded over the edges. The Autolite has very sharp 90-degree angles, whereas the Motorcraft is a little bit more rounded. And of course, the bigger chimneys, as I mentioned, a little bit different shaped air horn. But underneath the top casting is the main casting, and this here's the bowl, and it has a float and a needle valve, just like any other carburetor. Let me say a word about the bowl. The 2100s have a bowl that is integrated into the main casting. It's all one big piece of cast aluminum. Some carburetors, the bowl is a separate assembly that is then gasketed and attached to the main carb body. Holleys are like that. The Holley fuel bowl is not part of the main carburetor casting. And if the discussions on the internet are to be believed, apparently those bowls can and do leak where they're gasketed and attached. Obviously, that is physically impossible on a 2100 unless the main casting is compromised. Don't drop your carburetor. Also, the carb base is part of the single casting. You'll notice that Rochester's, they have a metering block in the base. There's no metering block in a Motorcraft or Autolite 2100. But Rochester's, the Venturi portion of the main casting is separate from the metering block portion of the main casting, and there's a gasket between the two of them, and they can leak where the two are gasketed together. But once again, this is just a gigantic piece of cast aluminum, so as long as it's not compromised, you should have no leaks to the outside world. Now these are the jets, and you only have one set of jets. Some carburetors have different jets for the idle and the throttle circuits, but that is not the case for an Autolite Motorcraft 2100. Idle and throttle both pass through these same jets. And you'll notice the jets are at the bottom of the bowl. The jets need to be submerged in fuel at all time. Holley's jets are in the side of the I think they're in the side of the main casting. They're not even in the bowl. They're in the main casting. I think the bowl is just an open lip around the edge. And that's one of the reasons why, and I believe the Carter BBD is the same. And I think that's one of the reasons why your rock crawlers, your four-wheel drive folks, like to swap out the carburetors with the Motorcrafts, Autolites, is because even at extreme angles, your jets are going to remain submerged. Whereas if this was a Holley and the jet was up here, you know, if you're at an extreme angle, you can expose the jet to air. And the carburetor doesn't work if the jets are exposed to air. But these are the jets. If you look closely, there are little numbers stamped into the jet. Sometimes the number is stamped on the side. It's either stamped on the lip there or it's stamped on the side. And that number is the size of the hole in the jet that actually does the fuel metering. This is how you adjust your fuel-air ratio. Is you have to physically put a different jet in to change your fuel-air ratio. And the Ford nomenclature is to use the size of the hole as the part number of the jet. For example, these are part number 0.48 jets. And what that means is the little hole in the middle is 0.048 inches. If these were size 50 jets, the little hole in the middle would be 0.050 inches. If they were size 55 jets, it would be 0.055. Holley does not do that. If you look at the Holley numbering scale, at the very bottom of the scale, for the smallest jets, they are indeed the same. But as you move up the scale, the number of the jet starts to differ from the hole that's in the middle. So the Holley numbering scale is different for its jets than the Motorcraft Autolite scale. But anyway, like I said, you have to physically unscrew them to change them. The only way, absent a vacuum leak, that you're going to change your fuel-air ratio is to physically unscrew the jet and to screw in jets with different holes in the middle, different size holes. And underneath the jet is the fuel well. Here's the fuel well. Except for the accelerator pump, all fuel that's ever going to be delivered into the engine passes through the fuel wells. There's one in this jet too, 2 fuel wells. So idle and throttle, including full throttle enrichment, all pass through the fuel wells. If you look closely, there's a little brass tube right there that is coming from the full throttle enrichment valve. Some people call it a power valve. But it empties into the same fuel well as the jet. And then from the fuel well, it goes into the Venturi cluster. Some people call this the booster assembly. And this is where the fuel wells come out. There's 2 passages there. Now if you look in the Venturi assembly, there's 2 tubes nestled inside of each other. The smaller diameter tube is the idle, for the idle circuit. And the larger diameter tube is for the throttle circuit. So, like I said, both idle and throttle are passing through the same metering passage. And the way it works is at idle, fuel gets pulled through the innermost tube up into the Venturi assembly, and then it comes back down. It gets pulled up and then down through these passages here. These are the idle passages. And it gets mixed with air. These are the air bleeds for the idle circuit. So what's actually coming out the bottom here is not just fuel. It is a fuel-air mixture through the idle outlet screws. And this is what the idle outlet screws look like. They have a tapered end, and depending on how much of that taper is poking through the outlet holes, that determines how much of that fuel-air mixture, the idle fuel-air mixture, gets delivered. Remember, the carburetor is upside down, so it's like that. Gets delivered into the engine. So that's the idle circuit. Now, the way the carburetor switches between the idle and the throttle circuits. At idle, there should be no fuel coming out of the annular discharge nozzles. If you have any fuel coming out of the annular discharge nozzles, you got a problem. Okay, all the fuel is going up, down, through those passages, and out the idle outlet screws. Well, in the Venturi bores are these two slots. And what happens is, as the throttle plates open, they expose more and more of that slot to manifold vacuum. And as more and more of that slot gets exposed to manifold vacuum, less and less fuel gets pulled up and around through the idle circuit, and more fuel is allowed to travel out to the annular discharge nozzles until the throttle plates are open far enough, they've exposed enough of that slot, you don't have any fuel going up and around to the idle circuit. All the fuel is going out through the annular discharge nozzles. And if you look closely, you can see little holes. These are hollow inside, and there's little holes to go around the edge, and that's what delivers the fuel into the incoming airstream. So that is how the carburetor switches between the idle and the throttle circuits. There's no check balls, there's no valves, no nothing. It just uses airflow alone, fluid dynamics alone, to switch between idle and throttle, which is a very trouble-free design. Now, at very high engine demands, which translate into very low manifold vacuum, it has a way to deliver even more fuel, and that is the full throttle enrichment valve, or the power valve. If you look closely, this is a little spring-loaded valve. You see it springy, opens and closes. And the way this works, this cover is a vacuum chamber. Okay? There should never have fuel under this cover. If you ever take this cover off and there's fuel under there, you either have a failed full throttle enrichment valve, or a failed gasket on the full throttle enrichment valve, or you just didn't screw it in all the way. This is supposed to be dry. Okay? This is a vacuum chamber. And it pulls vacuum through this little hole right here, a little hole right there, and that pulls a vacuum on that chamber. And what that does is that then pulls the full throttle valve closed. So there's no fuel passing through the full throttle enrichment valve. But as manifold vacuum drops at high engine demands, that vacuum chamber, isn't pulling the valve closed anymore, and so it relaxes. There's a spring that allows this to then pop up. Fuel passes around the edges through the valve that's now been opened, through these little brass tubes that are in the fuel wells, and then that additional fuel passes through the metering circuit and out the annular discharge nozzles, just like you had put a bigger jet in. It allows you to get more fuel delivered into the engine than the hole in that jet would otherwise allow, due to the drop in manifold vacuum. And then the final way fuel gets delivered in the engine is the accelerator pump. When you open the throttle plates, the air passing into the engine, the fuel takes just a microsecond to catch up to the air, the change in the airflow, because the air is lighter than fuel. Fuel is heavier than air. So it takes just a second for the fuel to catch up. And so carburetors have what are called accelerator pumps. And what that accelerator pump does is it squirts just one shot of fuel to compensate for the fact that the air, you'd have a lean drop otherwise. You'd have the air-fuel mixture would go lean because you'd have more air, and it's taken just a microsecond for the fuel to catch up to that additional air. And it's proportional. The harder or the more rapid the change in throttle position, the more fuel that's going to be discharged through the accelerator pump. The less rapid the change, the less fuel that will be delivered through the accelerator pump. And the way it works, this piece of rubber here, this is the other side of it, that is how fuel gets into this chamber right here. This chamber here has fuel in it. And as the diaphragm is closed, it's attached to the throttle linkage, and so as the diaphragm is closed, it pushes against this rubber flap here, sealing it off so the fuel can't get pushed back into the bowl. So now the fuel has to go through this hole here. And it goes through this passage here and through this hole in the center. Now the bolt that holds the Venturi assembly is hollow on the inside. Then it has little holes at the top. It's a banjo bolt, just kind of like a brake line bolt. And that bolt will allow fuel to come up into the center of the Venturi assembly, and then you can see the holes for those two little nozzles there. And what will happen is the fuel will squirt out those nozzles, and you can actually see it come out as a spray. It goes psst. And that is the accelerator pump circuit. And this guy, of course, has sealing washers and a little check ball inside. The only check ball that's in a 2100 is the one on the accelerator pump circuit, and its only job is to make sure that fuel only goes out through the accelerator pump, doesn't ever travel backwards. And then, you know, like all carburetors, there are air bleeds. It's just like the plumbing stack on a house. If the carburetor can't breathe, you'll get, you know, bound, vacuum bound. So those are the air bleeds for the main metering circuit. These are the air bleeds for the idle circuit. They're bigger than the air bleeds for the main metering circuit because this also is grabbing air and mixing air in with the fuel for your idle. And that is how a 2100 backwards meters fuel. Well, let me show you this carburetor here. It is instantly recognizable as being part of the 2100 family, but if you start looking at it, you'll notice that there's a few changes. There's this thing here. There's choke pull-off is hanging off the rear. Remember the earlier Motorcraft 2100s had the choke pull-off there, and of course the Autolites have it in the choke housing. By the way the choke pull-off works, it's connected to manifold vacuum through the carb base, and so the choke plate is closed, and then when you start the engine, the pull-off cracks the choke plate open. That's the purpose of the choke pull-off. Well, this here is a 2150 in the mid-70s, right around 76, 77. Ford made a lot of changes to their powertrain lineups. They got rid of the M block, the FE block. They introduced the M block. There was all kinds of changes in the mid-70s. And one of the changes was the 2100 and the 4300. The 4300 becomes the 4350, and the only really significant change on that is it became a spread bore. The 2100 got a couple of nuanced changes to it, and the one that probably causes the most mischief are these little rods right here. I cannot tell you the number of times I have seen people refer to those as metering rods or fuel metering rods, and nothing could be further from the truth. These little rods never see a drop of fuel. Or if they do see a drop of fuel, you've got real problems. I mean, look at how high up they are. If you get a piece of trash stuck under your needle valve, you will get fuel that high because the needle valve can't seal. But your carburetor is just going to be, if the engine's running at all, you'll know it. Now, these are variable air bleeds. Okay. Do you remember the air bleeds that I showed you on a 2100 Venturi cluster? Right there, the air bleeds. Well, on the 2150, they have been relocated to the top of the Venturi cluster. And what you've got are these little rods that raise and lower. Let's see if I can do this with one hand. Do it like this. Okay, see the little rods there? And what those rods do is they effectively make the air bleed larger or smaller. They're shaped like little baseball bats, so some people call them baseball bats. See, they're fat on the bottom and skinny up on the top, shaped just like a little baseball bat. So right now, with the rod down, the air bleeds can let more air in, which is going to actually produce a leaner idle mixture. Okay, and leaner operating mixture until the rods raise up. Now, as the rods raise up, that hole becomes smaller, and that will actually allow the carburetor to draft more fuel. So what those are is an attempt from Ford Motor Company to make the carburetor more fuel efficient. I suspect it's probably a magnitude of 0.01%, but when you're dealing with corporate average fuel economy requirements, that's a game of inches. Every 0.01% helps. I've driven the same car with both a 2150 and a 2100, and I noticed no difference in fuel economy. But anyway, so that's one of the changes that they made. And by the way those rods work, there's a little cam right here. If you look at a 2100, the underside of the carburetor looks different. So there's no cam. But the 2150 has the cam, and then right there is the end of that rod that raises and lowers the baseball bats, and the cam pushes on it and raises and lowers them. So that's how that works. But the rest of the carburetor is pretty much the same. I mean, you got the idle mixture screws, you've got the same full throttle enrichment. Everything looks pretty much the same. They did add in the top casting the high-speed, I think it's called the high-speed pullover, something like that. The theory is that air rushing past those little nozzles at very high velocity will pull fuel through that little tube there that is sticking down into the bowl. And so with the very, very high airflow, high volume airflow that the high-speed air bleeds, or whatever they're called, will pull that much more fuel for you. Look at how big that hole is. That is the world's smallest hole. So I do sometimes wonder just exactly how effective that is. But it's there. It's on a 2150. If you ask me, its only real purpose is to make the top a little bit more fiddly to put on. You know, when you're putting the top of one of these, you have to put it on like that and then rotate it around and drop it in place. But, you know, so be it. That is a 2150. If you're watching this video, I'm going to assume that you're familiar with Venturi drafting of fuel, which is kind of like carburation 101. But if you're not, let me just give you a thumbnail explanation here. Way back in the Renaissance, a Swiss scientist named Bernoulli discovered that the faster a fluid moved, the lower its pressure would be. And that's called the Bernoulli Principle, or the Bernoulli effect. And air is a fluid. We're not used to thinking of it in those terms, but it is a fluid, and it responds to the principles of fluid dynamics, including the Bernoulli Principle. So the faster air moves, the lower its pressure will be. In fact, that's how airplanes fly. The air moving over the top of an airplane's wing is lower pressure, moving faster, has lower pressure than the air moving under the airplane's wing. And so you have lift coming up from underneath. Well, the same principle applies to a carburetor. The air getting pulled through the carburetor, see those are the throttle plates down underneath, and as they open, they allow more and more air to get pulled through the carburetor, and it has to pass through this restricted area here. These are the venturis. And so as the air passes through the venturis, it speeds up. And as it speeds up, its pressure goes down, it decreases. So right here, inside the annular discharge nozzle, the air is lower pressure than the air around the fuel in the bowl. And that's the whole purpose of the chimneys. The chimneys allow air pressure to go into the bowl. This air is higher pressure than this air, so this air is going to push down on the fuel, push it through those passages I showed you, up, around to the annular discharge nozzles, where it'll be discharged into the airstream. And you know, the more air that's passing through here, the lower its pressure will be, which means you have an even higher pressure differential, more fuel will get pushed through. And the less air that's passing through, the air passing through the venturis here will be not as low pressure, so less fuel will get pushed through. That is Venturi drafting of fuel. And these Venturi bores come in different sizes, different diameters. And on a 2100, this is where the size of the Venturi bore in inches is located. This is a 1.08 inch Venturi bore carburetor. Back in the Autolite days, there was like 7 or 8 different Venturi bore sizes that you could choose from. Shortly after rebranding it as a Motorcraft, Ford simplified those down to about 4, and then shortly after that, they simplified it down to 2, 1.08 and 1.21. 1.08 is what Ford used on their own 2.8 liter V6, the Mustang Cologne V6. And so I use 1.08s on the DeLorean 2.8 V6 because it's a pretty good match. You know, the two engines were the same displacement, they had similar operating characteristics. So this is a 1.08 carburetor. That's all I use are 1.08s. Let me show you this scary looking thing on the side of the carburetor, which is really not scary at all once you understand what it is, what it does, and how it works. This is the choke mechanism. And the purpose of this is twofold. It does two things. One is it cracks open the throttle plates just a little bit, so your idle speed is faster while the engine is cold. And then the other thing that it does is it operates this plate right here. This is your choke plate. And the way it works is inside, behind this cap here, behind this plastic cap, this is what it looks like. And this linkage here is connected with a rod to the choke plate. So when this is closed like that, it pulls down on that rod, and now the choke plate is closed. And as it moves like this, it moves this rod up, and that opens the choke plate. And eventually it ends up like that. Now what causes that linkage to move is the choke cap. And here, some people call it the thermostat. This is the choke cap right here. And inside of it is this coiled up spring. And as the spring heats up, it expands. And as it expands, it moves this linkage. And that's what moves the choke. This particular cap is electric. It uses electrical resistance to heat up the spring. In the bad old days, they used air that was routed through the exhaust passages in the intake manifold. And they did not use exhaust. I've seen some people say they used exhaust to heat up the spring. No, they used hot air. Now what would happen is that tube would rust, and then you would get exhaust being pulled in through the choke housing. If you have a choke housing that's full of soot and exhaust byproducts, looks like the inside of a muffler, that tube is rusted through. That's on a hot air choke. Everything I use on a DeLorean is electric, uses an electric cap. Now, let me show you something else on the choke mechanism. When you start a carbureted vehicle, first thing in the morning, this is what your choke is going to look like. Okay, and you want it all the way closed. You don't want it cracked open like that. And the reason that that choke is cracked open like that is there's a thing called the fast idle cam. This is what's behind all that over there. This is the fast idle cam. And this is the setting of the fast idle cam and the fast idle screw when you turn off the engine. And if you look closely, this fast idle screw is stuck right here. The cam cannot rotate around. See, it's connected to the choke mechanism through a rod that goes right there. And the cam is stuck. But if I move that fast idle screw out of the way, now the fast idle cam can rotate to its cold setting. Not only will it close the choke, but now the fast idle screw, which is attached to the throttle plate shaft right there, is going to be cracking open the throttle plates. So I'm going to have fast idle and a closed choke plate. And what will happen after the engine starts is vacuum will crack it open, let the choke pull off, and then as it heats up, it'll open it the rest of the way. So when you're starting a carbureted engine, you do not need to pump the ever-living daylights out of it. I can't tell you the number of times I've seen people say, well, you have to prime the engine. You have to pump the accelerator pedal to shoot fuel. Because remember, every time you move that accelerator pedal, you're moving the accelerator pump. See, the accelerator pump is connected to the accelerator pedal with this rod. So every time you move the accelerator pedal, you're shooting fuel. into the intake manifold. And people say, well, you know, you got to prime the engine, just like priming a water pump. Pump and pump and pump and pump and pump. No, you don't have to pump and pump and pump and pump and pump. If you have to do that to start your engine, you got problems that lie elsewhere. All you need to do to start the engine is close this plate and get the fast idle screw at the highest point on the cam. And all you have to do is just take the tension off of the accelerator. All you have to do, watch the choke plate, all you have to do is just take the tension off. That's it. The engine is now ready to start. Real quickly here, let me show you one last thing. Like I said, Ford and Autolite use the same housing for the entire production run. The only real difference is the cast-in threads were replaced with a removable fitting. This choke housing originally had a removable fitting. I have a plug up underneath there. But this housing originally had a piston that went in that chamber there. That was choke pull-off. This here is a original, never installed Autolite choke housing with the piston. See the little piston there? And the way it would work is, there's your cold choke. You'd fire up the engine, and vacuum that gets routed to the base of this chamber here would crack your choke open. That was your choke pull-off. Is that there's the piston right there. So you go, and then it would crack the choke open. And even though Ford had gone to external pull-offs, they kept the chamber. There it is. This choke housing never had a piston in it, but there's the chamber for it. One of the little nuances of a 2100. So hopefully that has adequately explained the Autolite / Motorcraft 2100 series carburetor that I use for these DeLorean Carb conversions. It was Ford's frontline 2-barrel carburetor for more than a quarter of a century, and American Motors used it. And American Motors, of course, was more than just Gremlins and Hornets. They also were Jeep CJs and Jeep Wranglers and Jeep Wagoneers. So there were literally millions and millions of these things made. And you know, there's probably millions and millions of them still in use. It is an extremely common carburetor. It's extremely easy to get bits and pieces for them. The Chinese are making knockoffs. You can get a brand new, made in China, knockoff 2100 carburetor. eBay is chock full of them. I don't use them simply because I think the Ford originals have better quality castings, and there's really no reason to buy a made in China knockoff when there's so many Ford originals that are so readily available. But that's the 2100 series carburetor. Very effective fuel metering for your DeLorean.